Problem. Here we have p of x is equal to x to the fifth plus x cubed plus 8x squared plus 8. And anytime we have four terms, we want to see if we can use factor by grouping. So we know that we have a P and a Q, right? P is 8, Q is going to be 1. Okay, so we know that P over Q is going to be plus or minus 8 over 1, right? So we're going to use factors of 8 for P and factors of 1 for Q. So factors of 8 are 1 and 8 and 2 and 4. So we have plus or minus 1, 2 over 1 would be plus or minus 2, 4 over 1 would be plus or minus 4, and 8 over 1 would be plus or minus 8. Now, because we have four terms, it's a good idea to see if we can do factor by grouping. So here we have, before we even go any further, P of x is x to the fifth plus x cubed plus 8x squared plus 8. And let's see if we can do factor by grouping before we go any further. So we split it in half, and we see that our greatest common factor is x cubed, right? And so that leaves us with x squared plus 1. Well, if we factor 8 out of the right side, we also get x squared plus 1. So from this, we factor out the x squared plus 1, and that leaves us with x cubed plus 8. Okay, so from here, we can go ahead and set each factor equal to 0. X cubed plus 8 equals 0, and x squared plus 1 equals 0. So we apply minus 8 to both sides, and we get x cubed equals to a negative 8, and we apply the cube root. Now with cube root, with the odd roots, we don't put plus or minus. That's only with the even roots. So we get x equals to cube root of negative 8 is a negative 2. And sure enough, that's one of our possible zeros, right? Well, let's come over here and to the x squared plus 1, and we apply minus 1. And we get x squared equals to a negative 1. Again, we apply square root. Now we put plus or minus, right? And we get x equals to plus or minus I. Now, if the problem only asks for real zeros, you would only include the 2, the negative 2. But if it asks for all zeros, real or imaginary or complex, then you would include the negative 2 and negative I and positive I. And from there, that's all our factors, our zeros. Okay, now in class for this next one, one class I got part of the way, in one class I did the whole thing. So we'll just go ahead and do the whole thing on this one. We have P of x is equal to x to the fifth minus 3x to the 4th plus 12x cubed minus 28x squared plus 27x minus 9. Okay, so we're looking for our p, right, and our q, and we get p over q. We're looking at plus or minus factors of 9 over 1. So we get our all possible zeros table out, p, q, and we're looking at p over q, right? So factors of 9, we know are 1 and 9, and also 3, right? And we have the other one as factors of 1. So we're going to go ahead and apply 1 over 1 will be plus or minus 1, 3 over 1 will be plus or minus 3, and plus or minus 9. Okay, so let's take a look. Let's go ahead and put it in our calculator. And we're going to put in 1, or just x to the 5th minus, oh, there's 2, I only want 1 minus in there, 3, x to the 4th plus 12x cubed, and again it wrapped around here for cube, minus 28 x squared plus 27 minus 9. 28x squared, yeah, plus 27x minus 9. Okay, so we look at our second table, and we're looking for plus or minus 1, plus or minus 3, and plus or minus 9. Well, here's 1. We can use 1 as our first 0. Alright, so we know 1 is a 0. So here we have our polynomial. We'll rewrite this here, x to the 5th minus 3x to the 4th plus 12x cubed minus 28x squared plus 27x minus 9. And we know that 1 is a 0. So we're looking for the other factor. Okay, so since this is a really large polynomial, I'm going to give myself plenty of room here. So we use 1 as our divisor, and we're going to put in 1, negative 3, x to the 4th, x cubed, that's going to be a 12.